Next, we have the truth table for the biconditional operator. So let's go ahead and fill out our interpretations for our propositional variables. And the biconditional operator is going to return a value of true if and only if both sides of the biconditional share the same truth values. Otherwise, it will return a value of false. In our first interpretation, we see that they both share the same value, that is, true. So we will have a return value of true. In our second and third interpretations, however, we see that these values differ on both sides of the biconditional. So we will have a return value of false. And in our last interpretation, we see that the truth values on both sides of the biconditional are identical. In this case, they are both false. So we will have a return value of true. And this is the truth table for the biconditional operator. The truth table that you see here is also the truth table for the biconditional operator. However, it's just expressed as a conjunction rather than by means of the biconditional operator. And I'm just offering this because the biconditional operator can seem a little bit confusing sometimes. If you see here in our expression, we have P implies Q and Q implies P. And if we go back over to our biconditional operator, we can see that this arrow is pointing both ways. So we can say P implies Q and Q implies P. You can see the similarity here. Let's go ahead and fill out our truth table here for our propositions. And in this case, we have a repetition of propositional variables. So what might we do when we're presented with a case like this? Well, it's best to stay consistent. So in column AC, we see that it goes 1, 0, 1, 0. So we want to stay consistent here. We don't want to type something like this. That would be inconsistent. So we want to make sure that we have the same interpretation values for each repetition of the propositional variable. And same thing for P. We don't want to do 0, 0, 1, 1. However, we do want to stay consistent with 1, 1, 0, 0. And now let's just fill in the rest of the truth table. We already went over the semantics of the material implication. So we know that we will have a 1, 0, 1, 1. And here we will have a 1, 1, 0, 1. And our last operator here is the conjunction operator. And remember that this conjunction is comparing the values within column AB and column AF. It's not comparing the values of the actual atomic variables here. It's comparing the values of the operators, their return values. So again, let's just recall that the conjunction operator returns a value of true if and only if both conjuncts are true. If not, it will return a value of false. In our first interpretation, we have both true, so we will have a return value of true. In our second interpretation, we have a false and a true, so we'll have a return value of false. In our third interpretation, we have a true and a false, so we'll have a return value of false. And in our last interpretation, we have a true and a true, so we will have a return value of true. Look at column AD. Our truth values go 1, 0, 0, 1. If we go back over to our biconditional operator, in column X, you see the exact same values. That is, for each interpretation, both of these expressions have the exact same values. And this is how we tell that these two expressions are what we call logically equivalent. We can see again, we have the same exact values. And this is the truth table for the conjunction of two material implications. Our next truth table is just to show that these are indeed logically equivalent, right? We still have our biconditional operator here, and we have our same expression here. That's the conjunction of the two material implications. Let's go ahead and fill these out. And we can see here that we're incorporating another instance of the biconditional operator. And remember that the biconditional operator returns a value of true if and only if both sides of the biconditional operator share the exact same truth values. And recall here that we'll be comparing column AJ with column AP here. So look at this one, right? We have 1 and 1. So we'll have a return value of 1. Here we have 0 and 0. So we'll have a return value of 1. Here we have 0 and 0 again. So we'll have a return value of 1. And here we have a 1 and a 1. So we'll have a return value of 1. And you'll notice here that column AL, our main operator, has all values of 1. And this tells us that this expression is a tautology. In other words, that it is a theorem within the language of propositional logic. It's true in every possible interpretation. And being that it is true in every possible interpretation, we know that it is valid. If, on the other hand, let's say we had a 0 here in our main operator, this would not be a valid formula or a valid expression within the language of propositional logic. But again, since we have a column of 1s here, we know that this is a valid expression. And that is the lesson for today, guys. Thank you for joining us. I hope this introduction video helps you to better understand some of the grammar, syntax, and semantics of propositional logic so that you can follow along with the rest of this series. If you do have any questions, concerns, comments, etc., please feel free to reach out to either myself or Dave. And until next time, may reason be with you.